Tuesday. My name is Dale Dewiel, Senior Application Engineer, Solid Edge Specialist. And for the next 20 minutes, we'll be looking at some Solid Edge. It's brought to you by CAD Logic. The session today is entitled Solid Edge Multi-CAD Workflows. Basically, being able to work with various parts and legacy models and parts from vendors, customers, things that were not made inside of Solid Edge. As I said, this program is brought to you by CAD Logic. What is it? What do we do? CAD Logic was founded in 1995. We're headquartered in Oxford, Michigan. We've been in business for over 16 years. And we provide complete end-to-end hardware, software, meet those hardware, software needs and the training for the engineering market. The best way to describe what we do is to divide it up into three different areas: the 3D scanning, the CAD, CAM, and then the 3D printing. On the CAD side, we are a full Siemens business partner, so we provide the NX, Solid Edge, PMAT, and Team Center. We also do a spray for CAM as well. On the 3D printing side, we use a Z-Corp printer that allows us to take that CAD model, put it into the machine, have that model printed layer upon layer, and then when we take it out of the machine, we have a physical model. We can take to a trade show. We can, as you see on the screen there, the car made out of Legos. You can actually turn. You can turn those wheels and see how far it goes turn and things like that. And then on the reverse engineering or 3D scanning side, a couple of things we can do. We have the rotor arms and also the shape grabber allows us to go out there, laser line read your print or read your part, produce a CAD part, which then again goes right into I'm going to make a print out of it, or I want to go make a 3D solid object out of it using the Z printer. So what we do is just one big continuation of giving you the most effective use of your parts. Well, today we're going to talk about Solid Edge multi-CAD workflows. Now, a couple things just want to bring to your attention before we get started is that we do live and work in a technologically diverse world. And by that I mean, if you think of your cell phone, the different types of cell phones that you have, and then you think of the different types of carriers, cell phone carriers that you have. The same goes for cars, car insurance, computers that we all work on. They're all different, many brands. So the same way with in the CAD world, there's many brands that we all have to interface with. So Solid Edge isn't the only CAD program on the planet, but we're working on it. However, Solid Edge can use all popular CAD file extensions. And if you look over to the right of the screen, you'll see the first 4 or 5 are Solid Edge file extensions. After that, we go into Parasolid, NX, ASUS, AutoCAD, CATIA, IGES, Inventor, MicroStation Pro, ESDRC, and SolidWorks, and StepFiles. So all of those file extensions that you work with, and I think I might have missed out or left out IGES and JT, and they're in there as well. But all of those files that you work with on a day-to-day basis can be opened natively. Also, once the partner assembly is open inside of Solid Edge, that part becomes your part to either change or to lock down and say, no, I don't want to change it, but I do need it, so I want to preserve it. So today we're going to talk about creating from 2D to 3D, and then we're going to talk about merging 3D with 2D. Sort of, you can go one way, then we'll come back the other way. And then working with concept parts, taking imported models to completed assembly. So let's go ahead and take a look. The first thing I'm going to do is open a regular DWG, an good old-fashioned AutoCAD DWG. And as I do, I'm going to start to work with this, and using the Smart Select, we could stay down at this model. I could stay at a 2D model here. I could work with layers just for the sake of time constraint. We won't cover everything, but just for the sake of this, I can work with layers. I can work down here in the 2D world. But what I'm going to do now, though, I'm going to get rid of all the hidden lines. And I'm going to create a 3D file from this 2D. So we want to go ahead and take what we consider to be our front view, and that would be this. And then I'll go pick the next view. Notice I didn't say right or left. The program will determine what is the right or left view as per the location of the drawing. So as I do this, Solid Edge will go out and lay my AutoCAD sketches, if you will, my AutoCAD geometry, onto a 3D part, into a 3D part. As I take this, I'm just going to bring this web out just as far as the side view tells me to. We'll do the same thing with this, and we'll go bring these little bosses out here as far as the side view tells us to. And then we'll take our bigger balls up there and take it out just as far as the side view tells us to. Now, what's nice about this is that we can control this part by its dimensions. Dimensions that aren't used are made brown. Those weren't used, but these were. So this 0.1024 hole right here, if I make it 0.75, I can change if I type in correctly. It will actually change. So I can make that 3/4 of an inch. The nice thing about that is I can take something like this, and that's 1.575. Very easily I can make 1.5 inches and change that part. So I can control any part that I like, give it any type of intelligence that I want. Just for the sake of time, I'm going to make this radius down here, or that diameter, the same as that diameter. So, what is that going to do for us? So now this is 472. I'm going to take my middle mouse button and just scroll. And I can type in any information I want, but I want you to see that I've gone back and I've made those two equal diameter. Okay, so I can control my part. Now, moving on, let's go out and work with some other types of files that we have. And I'm going to go open a part. And I'm going to open a SolidWorks part. Just a native SolidWorks file. Just send us the file. We'll work with it. So we'll save this. And then what I want to do is I want to start to merge that with the 2D file that was sent with it. So I'm going to take this is the Transaxle Bracket, that's the name of the part. I'm going to take that drawing, the DWG, that was sent with it. This time I'm going to do a little bit different. I'm going to go look at this and preview this for a second. And just for the sake of time, again, I'm going to change this over to metric, because that's what the part is drawn in. And we'll go ahead and open that part. Now, I'll go create another 3D, but this time I'll add it to an existing file. I'll go out, find that bracket that I just saved off. And this time what I want to do is I want to take all of the dimensions that I have here. So here, I grab my front view, we'll set our scale. I'll grab my front view. We're going to do that again very, very quickly. Add to existing file. Next, I want to set my scale. And then, sorry about that, then I'll grab my front view, grab a top view, and then grab a right side view. Finish, Solid Edge is going to go out and put that geometry right on there. Now, we don't need to look at all of this, so what we'll do is hide many of those sets that we have. And we'll just take something like this. I'm going to take that front view that we have. I'm going to take that front view, and I'm going to go back, and I'm going to run that sketch those properties back onto, or the AutoCAD drawing rather, back onto that part. So when I see something like that, in fact, let's go over and clean some of this. So I'll take what I see right here and just run this right down over here. So I'm going to take this view right here, and I'm going to go attach PMI. And those dimensions are going to fall right down in place, right out onto the part. So we'll take that. We may hide that. We'll take this one. And do the same with that. And I just want you to see that as I take this, I'm going to attach my PMI, and my dimensions are actually going to jump over there. Now, I'm going to kind of hide some things that I've got. Take some things that we didn't use. Okay. And then we'll go ahead and look at the things that we did use. In this case, I just want to show you how I can control this. This is 40 millimeters right here. We're going to go ahead and make that, oh, I don't know, we'll make it 50 millimeters. So I'll just type in 50. So that dimension that came from the file, from the AutoCAD file, now imposes itself onto the 3D solid. What's nice about this is as I save that and go out and create a drawing of that, so I can have my drawing, and I think I'll scale it down just a little bit. Solid Edge instantly makes that top, front, and right side drawing. And I think I'll take, just to show you how this works, we'll come over here and a little bit of 3D ISO there and shade it. And then simply have it retrieve the dimensions that were brought over there to it. So you can see that I don't have to go back and rebuild a drawing. So in this case, I took a 2D, an AutoCAD, attached it to a 3D SolidWorks part, and then made a Solid Edge draft, a part and draft out of that. Now, let's move on a little bit, and I want to go ahead and talk about what I call a concept part. Now, in this instance, a concept part is something that somebody said, hey, can you make something like this? I'm not sure what I want, but can you make something like this? I'm going to say sure. So in this case, I've got a box. I've got a box that a customer had sent, and they said, I want this part made out of 16 gauge sheet metal or whatever. It goes into a part, it's a cover, but I need this part made. Can you go make that for me? Well, obviously the answer is yes. What we need, though, is the ability to take this box, whoever made it, and to turn it into Solid Edge sheet metal. Again, very easy to do that. I'm going to go rip the corner. Because this was a box, the corners really weren't ripped. It was just made hollow, but they said, can you make something like this? So we'll go rip those corners, and you can see that I've taken those corners and actually ripped them open that way. And then we'll also just transform this to sheet metal. Now, for the sake of time, what does that allow us to do? It allows us to flatten it. So even though the box came in on its own, came in formed, and it was just a hollow protrusion, we went out, ripped the corners, and made it a flattened piece of sheet metal so we could actually cut it out and build it back up. Now, let's go over and work with a few more objects that we have over here. I'm going to go set on all of my documents. And do that, right? Okay. And we'll go ahead, and I'm going to go open an Inventor part. We'll open our Inventor piece over here so we can start to work with that. And I've got a simple piece, and some of you may be familiar with this demonstration. But I'm going to save that. This is my Inventor plate. And then I'm going to go ahead and open my SolidWorks dice block. We want to open that as a part as well. We want to bring this down. One of the things that I wanted to bring out in the PowerPoint is how when you have a part that when it comes into the solid edge, that it is yours. So just by simply measuring this was 3.720. I just want to make it 3 inches. The part's going to go respond to my measurement. I didn't create the part, but it's going to respond to my measurement. So very strong, very, very powerful set of tools inside of the solid edge. So now we'll go ahead and open our last piece, which is a regular solid edge part. Get this very, very quick, and we'll go out with it. Okay. Now this is the solid edge part, and you see that it has features and holes and rounds and everything that we use to make that. So what we want to do is we want to take that and make an assembly out of this piece. And just bring that into our assembly environment. Now, to that environment, I want to go look at my parts that I have already open. That's a very nice new feature inside of ST4 is I can go to my open documents. I left all of that open, so I didn't have to go wonder where it was. So as I take this, I'm going to orient this in my catalog, in my preview, if you will, and then just do a very quick flash fit and have this part set right there exactly where I want it. Then we'll take the SolidWorks vice block, do the same thing, bring that in. What I'm doing now is called flash fit. We have other Tech Tuesdays and other training on that, but just basically by inference technology, it goes out there and it sets. Now, we'll go ahead and save this. And then I'll start to work with the piece that I have here, which is this vice block. We'll go ahead and edit that in place. We'll edit that in place, and I just want to show you how I can work with this model. What I'd like to do is I'd like to extrude. I'd like to take a face, if you will, and I'm going to take a face off of the solid edge face. So here I have a SolidWorks part. I have a solid edge part. I'm going to take the face off of the solid edge part, and I'm going to run it into the SolidWorks part. Again, it doesn't matter where this comes from. Once it's in there, it's mine. So if I want to make it 2 inches, it's going to come back 2 inches. If I don't care for the 2 inch, I think we'll go ahead and change that out, and we'll make that 1.5 inches. So doesn't matter where this part comes from. These parts are my parts when they come into the assembly or when they come inside of the solid edge. Doesn't matter if I created them, so I created anything that I like. Now, up to this point, I've been working in parts, and I want to change that because what I want to do is I want to go out and start working with faces. So in the context of the assembly, I want to do that, and I'm just going to go and say, I want coplanar, otherwise known as flush. I want this face to be flush to that face. That's all I have to do. Now, I can also take and drag faces as well, and you'll see that the solid edge, even though this is an Inventor piece, understands that there's just as much material on one side as there is on another, so it's asking me, actually, do I want to move both? And the answer is yes, and I can move both right like that the way I want to. So again, we'll just take and we'll just say, I want to make that coplanar or flush with there, and then both sides are actually going to move at once. Now, at this point, I want to take this face and pull this up, but you'll see that if I pull this face up, you'll see that the taper gets smaller. That's not quite what I want to do. There is no, since this came from an outside vendor, I'm not privy to what they were thinking when they made this, but I get to change the rules or even apply my own rules to this. And what I'm going to do is I'm going to have the face stay the same. I'm going to have the tip, the angled face, I'm going to have that change to where I want it to go. So now I get to go out and move faces the way I want to. So we'll go do that one more time. We'll go over and tip, and I'm going to move that face to be in line with that. Very strong, very, very powerful set of tools inside of Solid Edge. Now, a couple of things as I see this, just to show you that all parts are the same to me once they come inside of Solid Edge. To show you that very quickly, I'm going to take this hole and I'm going to go over to a thing called Selection Manager, and I'll take the hole and I'll say I want to find everything that's concentric. Solid Edge is going to go out and it's going to find this hole, the boss on the outside, obviously this hole and the boss on the outside. So when I move that, I'm actually moving those parts together. So I'm affecting a Solid Edge part, I'm affecting a SolidWorks part, and even the face, the Solid Edge part that I put onto the SolidWorks part. So therefore, it really just doesn't matter how that part comes in, who made it, did I make it, did someone else make it, what were they thinking, it just really doesn't matter. When that comes into side of Solid Edge, it is yours, it is your part to control any way that you like. All right, so just in the last 20 minutes here, we talked about 2D to 3D, taking that AutoCAD part, turning it into a solid. And then we took a solid, laid a 2D drawing on top of it, and then actually went back out and made our own drawing of it. We took that concept, that box, hey, make this cover like this. Well, okay, we need to flatten it and open it up. We took that concept part and turned it into a real sheet metal part, living, breathing, bendable part. And then we also talked about taking the imported models, the SolidWorks part, the Inventor part, put it on a Solid Edge part, and even stole faces off the Solid Edge part and put it onto the SolidWorks part. So anything that is needed to be done to get that job out the door, that's exactly what you can do inside of Solid Edge. So very, very quickly, let's talk about training. We do offer professional training. All of our instructors are certified experts in their field. So when it comes down to not only solid edge, but NX or Z-print or laser scanning, anything that we have, we offer that expert level of training. This webinar that we have is posted within 24 hours out on YouTube. We have a CAM Logic channel on YouTube. Please feel free to stop in and see this. You want to review it a month from now, a year from now, it'll be there. Well, thank you for joining us. Again, my name is Dale Dewiel, Senior Application Engineer. If you have any questions about what you saw today, feel free to give me a call. My number is 248-969-9201, extension 6209. And again, feel free to drop me a line if you like at dald@camlogic.com. We appreciate your time, and if you would, as I said, give us a call, give us a line. We'd love to hear from you. Thanks a lot, and enjoy your day.